All right, so let's look at this one. If I were to rewrite this, ladies and gentlemen, if I'm going to rewrite this, this is going to be the same as saying y over 3.5 equals sine of x over what? 5/4, right? Okay, so my b is 3.5, right? And my a is 5/4. The reason the a is 5/4 is it's really the reciprocal of this number right here. Yes. Yeah. Now I'm going to do s of xy equals 5/4 x and 3.5y. Oh, arrow. Thank you. Okay, so that's the scalar change. Now it says identify the amplitude. So the amplitude is always which one, A or B? Absolute value of B. So it's going to be 3.5. And the period is going to be what? Yep, so it's going to be 5/4 times 2 pi. And so that's 5 pi over 2 in the end.
You are such a...
So basically this theorem, properties of sine waves, is still repeating what I just told you guys. Y equals B sine of x over A. Otherwise, I just said it to you guys earlier to set it up like what we had last chapter. That means the same thing as this, okay? The amplitude is absolute B. The period is 2 pi absolute A. So the graph at the right shows an image of the graph of y equals sine x under a scale change. Okay, so what's different on this? What's the amplitude on this?
4.
It's 4, right? Which means that is also equal to B. All right, what is the period on this? It repeats like starting here, right? From here to here. What is that point right there? It's between 135 and 225, halfway, and I think that's 180. Okay? So your period on this is 180. No, this is supposed to be a sine wave. Notice that it's starting here, it's going down instead of up. So what do you think that's going to do to your B value? Yeah, it's going to make it what? Negative. Okay? Because it's going down instead of up. Okay, so let's find out now what our A is. We know that our period is 2 pi absolute A equals 180. So how do I solve for A? Yep. Okay, so my absolute A is going to be 90 over pi. So it can be either positive 90 or negative 90 over pi. Oh, guess what, guys? Let's go back. Because you know what? I went from radians to degrees. So what is my period in degrees? 360. So let's go back and fix this. So this should be 360. I'm sorry about that. Okay? So A is 1/2. Could be positive or negative 1/2. Okay? Now, I'm going to always use the positive in this case. Okay? Um,
Are supposed to use?
yeah, I would assume positive. Assume the positive. So in this case, if I'm going to set this up, remember it's going to be y over b equals sine of x over a. So y over what? Negative 4 equals sine of x over what? 1/2. So now if I simplify this out, what happens to that negative 4? Well, not positive, but it goes to the other side, right? So it's, if I multiply both sides by negative 4, so it'll be negative 4 sine. And then what happens to this 1/2? Yeah, so it becomes 2x because you're flipping it, right? Because you don't want to have a fraction on the bottom. So this ends up being your formula here, okay? Do you guys have any questions about that? The next example is a cosine. So the little one here is a regular cosine. The big one has some changes to it, doesn't it? Yep, we're supposed to find the big one. So what's the amplitude on this one? Yeah, it's 3. Okay, so that is also your B.
So would it be, negative?
Well, good question. If it were negative, here's where our start of our cosine always is on the top, right? So it's not going to be negative. If it had started down here instead and went up, then it would have been a negative. Okay? So we're starting here, and we go down and go back up, and here's the end of our period right here at 6 pi. So what's our period? Mm-hmm. Okay, so we're in radians this time. So if I want to find A, I know it's 2 pi absolute A equals 6 pi. Divide by 2 pi. So A is 3. Pi's cancel out. Okay, so how am I going to write my equation?
Y over 3.
Yep.
Sine x over 3.
Yep.
And then y equals 3 sine 3x.
Actually, this stays the same because it's not in fraction form anymore. Good. That's it. All right. Seaver had a blonde moment. This should be a cosine.
Oh, all we do is change the.
Yeah. There you go. No, it should be a cosine. That's what it says. Sorry. Okay, so the frequency of a sine wave. Notice the graph of cosine in example 1 completes 3 cycles for every 1 cycle completed for this one, for this graph. In this case, we say that y equals cosine x has 3 times the frequency of y. The frequency of a periodic function is the reciprocal of the period and represents the number of cycles the curve completes per unit of the independent variable. Thus, the frequency of the cosine function is 1 over 2 pi, because 2 pi is the period, right? So what is the frequency of this function? It's going to be 1 over, remember A is our 3, right? Times 2 pi, that's the period. So it's going to be 1 over 6 pi. In sound waves, it is common to view the x-axis as representing time. and the y-axis representing pressure. Typically measured in newtons per meter squared, or big N over little m squared. Okay, I know there's some ones like this in your homework, so follow along as closely as you can, okay? Okay, so the tuning fork vibrates with a frequency of 512 cycles per second. The intensity of the tone is the result of a vibration whose maximum pressure is 22. Find the equation of the model of sound wave produced by a tuning fork. Okay, first of all, I need you guys to know that the intensity, remember, is the amplitude. It's also the volume is what they're talking about. Okay, so in this case, the intensity is 22. The frequency was 512. That is the same as saying 1 over 2 pi absolute A. So I want to solve for A right now. The first thing I need to do is get it out of the denominator. So I'm going to multiply both sides by 2 pi A. Okay? So 512 times 2 is what?
100. Is that an A receiver?
Yeah, that's an A right there.
Don't you have to multiply by 2 pi A?
Yep.
Is that what that is?
Yep.
It looks like a
Yep.
number.
Sorry. And it's pi here and still an A equals 1. So now how do I solve for A? Yep. Divide by 1024 pi, right? Okay? So I got an A, I got a B. So let's write this out. We have y over b, which is 22, equals sine of x over 1 over 1024 pi. What happens to the denominator on this? We're going to flip it up, right? Okay, so what happens to the denominator under the y? Right, we're going to move it to the other side because we're going to multiply both sides by 22. So this ends up being y equals 22 sine. And then this becomes part of the numerator. So it's going to be 1024 pi x. Yes? Why is it sine?
Because sound waves are sine.
Yep, we measure sound waves in sine. Yep. Any questions? Okay. We already know that we have a frequency of 440 cycles. So we know that 440 equals 1 over 2 pi absolute A. Okay? So if we multiply both sides by 2 pi, we get 880 pi absolute A equals 1. Then if we divide, we have A equals 1 over 880 pi. And we know that the pressure is 15, so that's our B. So it's going to be y over b equals sine of x over 1 over 880 pi.
So would it be y?
Yep. Yep. Yep, there you go. How are you guys doing? Okay. Good. You guys are doing great. All right. Knowing the number of cycles per unit of an independent variable can help you solve trigonometric equations. Without using technology, determine how many solutions each equation below has in the interval between 0 and 2 pi and confirm your answer with a graph. Okay? So, on this one, how do I find what my A is? What would be my A in this case? Yeah. A is 1 over 3 because you know it's the reciprocal of this number, right? Okay? So if A equals 1/3, that means each cycle is 1/3 the size of cosine x.
Wait, where did it 1/3 from?
Because it's the reciprocal of this right here.
Oh,
Okay? So, this particular one, this equation has 3 cycles and 6 solutions. Okay, so the reason why we know it has 3 cycles is that this is 1/3 of the normal cycle, so you know that it has a shrink. So it's going to repeat 3 times between 0 and 2 pi. And because of that, if you think about a cosine wave, it's doing this, right?
Wait, how did you get the solution?
That's what I was about to talk to you about. Because at 0.8, if I'm going to go to 0.8, it's not quite 1. Look at my graph here. Okay? So how many times does it go through 0.8? We got 1, 2, 3, 4, 5, 6 times. Okay? Okay, B. What's my A in this case?
2.
Yep, A is 2. So that tells me that each cycle is 2 times as long as tan. Now, how long is a tan cycle? Pi, right? Tan being pi. So one cycle, one cycle in this case is equal to 2 pi. So how many times how many solutions are you going to have in this case? How many times does it hit 3? Once. Because if you think about pi, you're going to have one going like this and then the other one coming up like this in a 2 pi cycle, and it only hits positive 3 one time. So one solution. Make sense? Kinda? I hope. Okay, so we got 2 more to go through here. Okay, so what's my A in this one? 4. Good.
So would it be each cycle is 4?
Yep, 4 times the amount of regular. Oops. Okay. And then, so how much of a cycle do you have between 1 and 2 pi then? Not even 1. Because how much is, usually you have 1 cycle between 1 and 2 pi, right? But if this is 4 times the length, you only have 1/4 of a cycle between 1 and 2 pi, or between 0 and 2 pi. Okay? So, and then it says, when does it hit 0.75? How many times between 1 and 0 and pi? Actually, if you think about a sine wave, it's going up. Yep, it hits once. So a lot of this, you guys have to get good at envisioning it in your head. Should be at least once. Okay, the last one. What is B in this case? 1/2. All right. That's what I meant, A. All right, since A equals 1/2, we know that the cycle is 1/2 as long as the normal tan cycle, which usually equals pi. So how many 1/2 pi's do we have between 0 and 2 pi? Well, that means that we have 4 cycles. And when does it equal -14? If you remember, tangent is doing this. So it's going to have 4 solutions.